references and references. Okay, well, I haven't shown you an example of unique and references. I've only showed you an example of references. And getting into whether unique or not is something a little bit different. So we're going to talk about this today. We're going to talk about keys a little bit more. We'll deal with the flights database that you just set up and show you how to define primary keys and foreign keys for that. And when you specify a primary key, by the way, so let's look at some documentation here. This is off the official Docs, Microsoft Docs site. Here's a reference to primary and foreign key constraints. It took me a little bit. Search normally search takes you to other places first, but I go back to the documentation. Although there's lots of places to search for this stuff, it's amply documented on the web. Go to the official documentation. Also go to the other sites. Stack Overflow, you'll see a number of database-oriented sites, SQL Server-oriented sites that'll show up when you Google this thing. Google primary and foreign key constraints, though. Here we go. So let's see what it says here about primary keys. It says a table has a column or combination of columns, and I haven't been clear about that, but you could have a combination of columns, and I showed you an example of that at the end of Friday. I'll go back to that in a minute. That contain values that uniquely identify each row in the table. So primary key is built in the idea that it's unique. It uniquely identifies a row of the table. You call that a primary key. And the table, the document says, enforces the entity integrity of the table. In other words, you can't store another row in the table with the same primary key. It'll reject it. That's what they mean by enforcing the constraints. And it mentions they are frequently defined on an identity column. I mentioned identity columns. It's a particular type that's unique to SQL Server. It might also be in Oracle. It's certainly not in the standard SQL types, and it's not in SQLite. We're not in Kansas anymore. One of the things SQL Server makes it really easy to do is to set up unique keys for you that can be used as primary keys. I mentioned that the last time, where you don't have to know what the next good unique value is. The database keeps track of it itself. It talks about the other thing that happens with this is that the primary key is used in queries. This query, what happens is having a primary key for a constraint on a table means it creates an index for the primary key column. And we're going to see how the indexes, actually I'll show you a little bit of that today, how the indexes affect the queries that you run, basically how they're compiled and run and used to generate more efficient plans. So we talked about this a little bit before when we talked about foreign keys. We're adding a little bit more to it. So in my answer to the question, I wanted to clearly differentiate unique as a constraint that is associated with defining an index. References is something involved with a foreign key. A foreign key column doesn't have to be an index. It could be an index, but only if you specify it as an index, and it could be unique only if you want to specify unique and in fact has unique values. Lots of flexibility. The thing about a foreign key is it points back to a primary key in a different table. And we're going to see how what's involved in that constraint is that primary key value must exist. And we'll show you also what the database does when, for instance, you go and try to delete that primary key, which would create an inconsistent database. There's logic to handle that automatically. Okay, how are we doing with that explanation? And that's all reasonable. Now, this all goes back to the, let me put this out of my way. Well, it goes back to this guy. We're talking quickly about multi-way relations, and this is where things started to get a little bit more complicated in terms of data modeling. And there's no wrong or right answer here, but what I was leading up to was what the question people have when they look at this kind of data model. We have products, we have company, we have persons. I'm not sure I like persons necessarily. That seems a little bit inadequate for what we're doing. It's more like customers, don't you think? But anyway, yes, it turns out, and I'll show you a good case or a good example of why in many cases, when you have a kind of three-way or four-way or five-way, multi-way kind of relations, it's useful to actually have an explicit links table. If the relationship is just binary, just between two tables, like the primary key, foreign key one, you could represent it with a primary and key and a foreign key. You don't need a links table. And the link is implied. That's a link. Foreign key means it's a link. And you store that value there, and it is explicitly a link when you define it, and we'll see how those constraints work. Otherwise, you might think from this kind of data modeling that we do that you always need to represent the relation. And sometimes you do. And here and then we're going to an example of, and just this is kind of as an aside, you know, I inherited these slides from other people that teach this class. Here's the product table, here's the company table, here's the person table. If I were doing this, I think I would use customer, because that's really what it is. You might have other persons in the database. If this is a corporate database, I have persons who are employees. You could say, if you were thinking about this in object-oriented terms, you know, it's a subclass. A person who's a customer is also a person and might take on all the attributes of a person if you were doing this in an object-oriented way. So there's no easy way to do that in relational databases, but we do have this idea of a weak entity set, which we'll mention. Okay. Now, so here they have explicitly defined a purchase table, and they've defined a foreign key here that references back to the company name, and that's a primary key. That's good, and that company name must exist before purchase gets written into this table. And then there's a product name, and that goes back to the product table and that primary key, and that's good. And then we have this person ID, and it referenced the person table. And since it's the same field name in both, this is the same field name here, we don't have to specify what person, what attribute in, you know, what column in the person table. It's assumed if there's no column there, that there's a column that exists. By the way, if that column didn't exist, SQL would throw up an error for that either. Now here's where I thought it was pretty interesting. So somebody specifies a primary key of the company name, the product name, and the person ID. So that's the first time in this class we've encountered a key that is a compound field, but that is perfectly legitimate. And often indexes are made up of a series of columns. For instance, if you wanted to make a key out of a name, you might do last name, first name, middle initial, and you would maybe get a unique key out of it, or you'd figure out some way of disambiguating them. So you could have multiple columns that are associated with the key. What happens with a primary key, though, that's a very important constraint in that it specifies that this is unique or uniquely identifies a row. And there's another implication of a primary key, which is going to set up an index on that, using that key value to create the index. We'll see that data structure in another week or so. It's called a B tree, related to binary trees that you studied, but an extension for it that's used a lot in relational databases. So the thing about a primary key, though, is we just saw that it has also, so it turns into an index, and it has built in a unique constraint. Primary keys must be unique for each row. And that set off got me to thinking a little bit, because there's a problem with that model. And that problem is, what if the same person wants to order the same product from the same company again, well, that violates this primary key constraint. There's no way for me to put that in there. What'll happen is if that person tries to order it with this database design, that'll be an error condition. So I'm suggesting that the way I would do that is to generate a unique product or purchase order ID field and support the ability of a person to order the same product again, maybe differentiated by the product ID, by this, not by the product ID, but the purchase order ID, which is in fact probably how we do it in the database. So yeah, so I was looking at that, and that this slide is wrong. Well, it's not wrong. The model is going to produce in behavior that you're not going to find very useful to you when you try to, when you have a customer that tries to order the same product again. It's going to collide against this constraint because you have no way to store it. You're going to have to restore it as a unique field because it's a primary key. Okay, so a couple points. One is keys can be multiple columns, and the constraints associated with a primary key are that it is unique. It uniquely identifies a row. Okay, any questions on some of that? Sorry, I'm beating a dead horse if I am. All right, so I think that's around the time that we left off. Do I need it? Okay, so I do want to get to, let's talk a little bit. I want to get to a couple of things. Let's finish up constraints first, and then we'll go on to look at your SQL Server databases that you're either doing in Azure or doing local. Okay, so picking the right entities is very important. Your data model should be, what's the right level of complexity? Complex enough to support the use case scenarios you know about, but no more complex. Data models evolve. So it's very likely that you start with the specification on the previous slide that turns out to be a mistake, and you catch it when that mistake occurs. So I guess you don't really catch it. You change the model. One of the things about relational databases is you can add columns. You're somewhat flexible. Okay. As far as this, so they emerge, and that's where the data independence in RDBMS is a real asset. The other thing I thought I'd mention about ER diagrams is something called a weak entity set. And a weak entity set is one where you haven't specified the full key. You only have a portion of the key. And for instance, here we have a university that has a name, and for some reason we can understand the size of the university. And it has an affiliation with a team, which has a sport and has a name and a university date, whatever the sport, and I guess the name of the team, or I don't know, Huskies. I'm not sure what's being talked about here. But what we're saying is that this is a weak entity set because this is not necessarily something which uniquely identifies the team. It's phone numbers. If we have a table of phone numbers for you, and in that case, you're going to have your ID plus one of your phone numbers, and your ID and another one of your phone numbers. So in that case, your ID doesn't uniquely identify a phone number. And it's possible that people could share a phone, I suppose, but maybe the phone is unique, but that's sort of a different thing. So that would be another example of a weak entity set. Not that important a concept particularly. And one more concept is inheritance. This is a big deal in object-oriented programming. And so you would have here's a product, and you either have a product, type of product that's a toy and has maybe a field attribute associated with like what age is appropriate for, or in this case, you might have another kind of product category that is a subclass of product, and we want to know if it's candy, and we want to know if it's chocolate or it has peanuts because people have an allergy. So subclassing is something that goes on in modeling, in creating data models, because that's kind of the entities that you're dealing with. Okay, let me move on from that. Just a note here, which is that subclasses are mutually exclusive in object-oriented languages. Most of us that are interested in kind of semantic modeling, semantic models of various kinds, understand that that's a pretty serious limitation. But in fact, it's difficult to implement. So most object-oriented languages just allow one, you inherit from one thing, which is a limitation, serious limitation in really doing these inheritance networks. Okay. What is when you have inherits and subclassing with these things, you inherit these superclass attributes in its key. Okay. A product type, and then these are the product types have their attribute. So as you're modeling, creating a model, you might find these things and you're challenged to create a data structure to support that. What kind of table do I want? They use these diagrams also keep track of other constraints, like how many of them can there be. There has to be at least one, or there's precisely one, or at most 3 companies. That's a bad example. Okay, constraints. So we've talked about a couple of constraints. These are added into the database itself, and the database will check to make sure that the data you insert to the table passes those constraints. So here we put a check constraint about age in this particular table. Here we require that email address not be null, or that they at least have a phone number. So that's pretty straightforward. If you think you're adding a condition before you can add the data to the database, and these enforce the data integrity of the table that you have. They keep the data in the table clean, which is a huge benefit. So there are check constraints that are pretty straightforward. They're on columns. What else have I got to say about that? Okay, referential constraints. So here, let's consider what the database should do on execution of a SQL statement collides with a foreign key constraint. So, and I have a products table. It contains, this is the toys or something that we're still doing, and contains a foreign key entry for a company name called IMEO, whatever you say that. Whatever they make, I don't know. And my program tries to delete from the company table that row of the database. And the referential constraints that can be specified is that are either on a delete or on an update. So you can specify different conditions. What happens when you try to delete? What happens when you try to update that field? Because you're not just updating the company, you're affecting the products table that contains those foreign key entries. Okay, so the default behavior is no action. In other words, the database not taking any action. It's not going to let you do it. It's going to raise an error, and your delete or your update is rolled back. But that's a default action. This is an error. And then these other options are, well, it's not an error. I'm going to let this happen, but I want you, the database, to fix it. And we have 3 options there. One is cascade, which is that it automatically fixes the referencing table. On an update, the corresponding rows in the table where the foreign key are automatically changed. And on a delete, the corresponding rows are deleted. So they're gone. So you got to be careful what you do when you delete. You may delete something, but you want to keep some history around. You're not sure you want to keep other corresponding rows. But anyway, those are the options. You have to choose the option that you want. If you do a set null, it automatically fixes the reference table, but the foreign key column then must be nullable. Otherwise, you're going to have a problem with that constraint when it tries to execute. I think it'll let you set it. I don't know if it checks to see if nulls are nullable. It may not even let it. It may not let that go through. It'll check itself. And then we haven't used the keyword default, but you can define a default value for a field that is, in case you might have an insert into a table and you only know a couple of the values of a couple of the fields, and you can let the rest of the fields default until you have more information to update them. And if there's a set default, the default value for that column, that foreign key column, must have default value defined. Makes sense, otherwise it wouldn't work. I've got examples of this, of how all this works. Let's just do it quickly on an update cascade. Here's the company, Hasbro and Knife-Form. Here are the products. Beyblade and it's made by Hasbro. The Troll is also made by Hasbro. What happens if we change the name of the company and change it to Imeo, where it used to be Hasbro? Well, on update cascade says, okay, if you change this here, automatically change it wherever this foreign key is referenced. Where this value here is referenced as a foreign key. It'll do what you like there. It'll go ahead and change it. So this is where it is initially, and after it runs, it's going to be that. And now this integrity of this foreign key relationship is automatically maintained on an update. I think we've got an example on what happens if you want to delete. So I'm going to delete that company, and I don't want to delete the products, but I don't know who makes them anymore. So I guess I'm happy to set them to null. Okay. If we set, the question is from Lauren, if we set default and we have more than 2 wrong entries, won't the default violate the unique rule? Well, okay, so this is your fundamental misunderstanding, is that what's unique, Lauren, and the person who asked the other question, what's unique in a foreign key reference is not the value in the table here. This does not specify unique. It's not even indexed. What this does is refer back to a primary key. So there is no uniqueness constraint here. The uniqueness constraint is here in the company table, and where that value name, if that's the primary key, has to be unique. The foreign key restraint doesn't have anything to do with unique. What it does have to do with, except that it's pointing to a primary key and those values are unique, what it says, that primary key value must exist in the table where you reference it. So that's the answer. So don't get confused about unique. Now, if you wanted to, we'll find that we might want to create an index here. I don't know why, but you could, because maybe you search through the product table to find the companies. And then you could create, but in that case, it's not going to be a unique key. It's normally, these are called secondary keys. It could be a foreign key, but they're not necessarily done to be unique. What's unique and what's constraint is the primary key constraint. That specifies unique. This is a referential constraint, basically says, hey, that value has to exist. And if it's going away or if it's changing, what do you want me to do? No action would be when I try to change Imeo, and in fact, there are company values here. It will not let that'll violate the constraint. It will not let that statement execute. That's what the standard one is. We alter the product and name and company. No. If you tried to alter that name in the product table, that's your other question there, you could do that. And as long as you, you wouldn't want to do that ever. You'd want to go just to the company and then change the products because of that relationship. But if you did, legally, you could change this. You'd have to change it to something that's already in the company as a named key, because otherwise it would violate the references. So you could do it. I don't know why you would do it. The way to do it is to change the company, and then it'll automatically update the foreign key references. But yeah, you could do that if you wanted to. But again, references is a constraint and says that value has to exist. So then these are the actions that are going to occur automatically when you try to change those values, and they no longer exist. Any more questions on that? Hopefully that's a little better explanation than what we had before. Let me, I think I got a poll for you guys. How do I get the poll going? Ah, where's my poll? Ah, here I wanted to know. Would you guys answer that poll for me? Let's see my email. God. Okay. That's probably most of the people that are. I was just asking because when I went out to Azure, I have a dashboard that looks and see how many of you have installed, and I would say not very many yet. I hope you're going to start working on it this weekend because you're liable to run into some things that are unexpected and new for you. So I would get out ahead of this if you can, and don't wait till the last minute. That would just be my advice. But it's going to be a lovely weekend. The parks and beaches, I think, are going to be open. You may have other things you want to do this weekend, but just try to get out ahead of this a little bit. Also, so that you have another lab section coming up on Thursday before the homework is due. Any questions that you have about that, about how to install and run this stuff, hopefully could be done there. Let me do a little demo, though, for those of you. So that's good. And this demo applies to, well, I'm running Windows, but would work whether my database was on Azure. In this case, my SQL Server is on Windows, but I can connect this tool to Azure as well, or any SQL Server that I have credentials for. So this is the SQL Server Management Studio. I've got the flights loaded here. I have a bunch of other databases. I use this I use SQL Server for testing and development. So the first thing I've done, the first thing I did was when we imported this, I noticed that things like the carriers, if you did the import, if you use the local version of SQL Server and you're restoring from a backup, it's set up for you. Because when I took a look at this, when one of the TAs did it, there were no indexes set up automatically. So maybe I've got a sample of that myself. Okay, that's good. So when you import this yourself, you're going to have something like carriers, and you see that it's a varchar, which is a shame. If you do it in Azure, there's a better import tool, but if you do it locally, it's not such a good tool. So what I did was I'm going to run a series of statements. First, I got to tell SQL Server to use this database and not the other databases. And what I'm going to do is I'm going to alter these tables, issue an alter table, alter column on these tables that basically says make those fields not null. Make those fields not null because they are showing up as null. If you refresh this guy, it'll now show up at their looking better. Now it's not null. Once those fields are not null, I'll post this script for you, by the way. Then you can do things like, well, add a constraint to it. So what I want to do here is add a constraint and define those fields, these guys, as primary fields, as primary keys. Now, it looks like I know what I'm doing here, right? But in fact, I don't remember what the syntax is of this stupid stuff. I've fumbled around. All demos should be taken with a grain of salt. You should, there's all this behind the scene work. Now it looks perfect. It all works, but it didn't work. It didn't look this way when I was doing it. Okay, so I'm executing that query. Notice that takes a little bit longer, even though my database is not in Azure. My database is local, so it's faster than Azure. But involving creating the primary key was a lot more complicated than altering the column because it's now creating an index on these guys. So now let's refresh this guy and see what my properties of my tables look like. And you will see for carriers that the columns, there's a little indicator there that it's a primary key now. And when we look at the keys, we will see a primary key constraint. You can open that up and look at it, but it's not going to mean too much to you at the moment. And why it took a long time was in the creation of the indexes. Now, once those primary key indexes, and this is the order in which you have to do this, first change the fields so they're not null, otherwise he won't let you define them as primary keys. That's another constraint on a primary key. It can't be null. And we're out of the realm of SQLite. SQLite may let you do some of this stuff, but it's wrong. It shouldn't let you do it. And now I'm in position that the primary keys are defined to issue a bunch of altered tables that add foreign key constraints. Okay, so let's execute that. And now I've got my foreign keys. All right, so if you haven't done that for your database, once you get it imported, if you see this problem, you'll want to run this script. I'll post the script out on the discussion board. Well, let me show you another script that I put together. And this is a little different. Let's ignore the first couple of states. So let's just look. What we're going to look is just this for now, this one statement, which is a pretty simple statement. I want to see the origin cities from this database. And I just want to see distinct values. All right, let's execute that. Now, what I'm going to do here, by the way, is I'm going to add a plan by clicking on this little button up here. This UI is miserable, I know, but it's got a whole lot of stuff in it. And one of these little widgets here says include the actual execution plan. We're going to look at the execution plan from this simple SQL statement, which you know how to do. You know what I'm expecting. I'm expecting a result set of just the cities that are in the origin cities in the flights database. Okay, let's execute that. And I get those cities. That's great. They'll tell me that there were 327 rows. That's nice to know. There are 327 different cities, in case you're doing a network. Now, this is probably something you haven't looked at yet. I'm guessing. This is the execution plan for that query. I'm going to make it as wide as possible. This is not the most visual thing. The first stage is a clustered index scan. It tells you what table is being used. Sorry, there's a pop-up help there. And it tells you that it's using the primary key, which is the flight ID. Well, that's about right. It's going to scan that index, but it's not scanning the data so much as it's scanning the index. And then it's going to do some kind of a hash match. It's going to do some parallelism. It's going to do sort, so some more parallelism. And finally, it does the select. So those are the steps that SQL Server executed on behalf of that query. The most important one is this step here, which is 99% of my cost. And the pop-up actually gives you detail on the number of rows that were read. And it shows you the estimated number of executions, estimated number of rows, and the actual number of rows. This is information that SQL Server keeps about each table. Is how big it is. It's cardinality, if you will. And these estimates are used when you're trying to decide, SQL Server is trying to decide what's the best query execution plan for you to use. Okay, well, so here I see a number called 114. Is that the right number? Let's do this just in case, because I don't trust anybody. I got off there. Let's not new query. I hit the wrong button. And you see, I'm just want the count of any old field. And by the way, what's that execution plan look like? So that is also a clustered index scan. There's some stuff here, parallelism. Most of the cost, of course, is in scanning those 1,114,000 rows. And there's the count from the first time that I did it. Okay. Are we supposed to do this for your homework? I would. It's going to make your homework run a lot faster to have indexes. And that's what I'm trying to motivate here. Yes, I think it was set up for you in SQLite when you did it, or you made those modifications and you added referencing. We haven't done that here, but you should do it. And I'll publish the script so you don't have to think about it too much. I call it additional DDL or something like that. I'll post it to the discussion board. Okay, notice this is pretty much the same query. It's executed the clustered index scan. It goes through all the rows again because it's the same query. It's a loop through the flights database. But the interesting thing is there's this clustered index, which is associated with the primary key. And all of that's there. See that down at the bottom where it says the objects, that's the flights, that's the database owner, this is my table, and it says FID primary key. The index that was automatically created on the file once I defined a primary key. Before we made those changes, that primary key did not exist. Okay, now let's look at this query. You with me so far? So this is select the FID, the flight ID, the day of the week, the origin city, the destination city, and from flights and weekdays. This is not a great query to run, but there's going to be a join here. Because there's a from, there's an implied join. And let's execute that query. And notice the plan didn't show up yet, or maybe I need to do it again. What happened to my plan? I didn't execute the plan, sorry. Let me go up here, it's still running. It's still running, it's still running, it's still running. Why is it running so long? Because for every row of the flights database, which is 1 million strong, it is joining the weekdays, the day of the week to it. That's not really what we wanted, is it? What we wanted, I gotta wait for it to finish though. If I can stop it. Not really. You can't stop it from here because it's actually executing inside SQL Server, which is a different process entirely. So this wasn't that good an idea. I need the where clause, yes indeed, which is right below it to make it a join. While that's running, let's do another one. And he may not let me do it. Oh, it finally executed successfully. Let's look at, I wanted to get to the explain. So this is an implied join. And what we have is we're reading through the flight database, all 1,114,000 rows. And we're reading through the days of the week database, which has a total of 8 rows. I don't know why it has 8, but I guess it does. And then it's going to do a nested loop join and put them all together. So this is costly, this is costly, all of this is costly. That's why it took so long, even though it's doing it in parallel. So that's why it took so long to do. Now what I need, as somebody pointed out, is I need that guy. But remember that the join, that's all it knew from your query. So that was a nested loop join. What I really wanted to do was make an equa join. So here I do it with the where clause, and I'm just looking for, I just want the day of the week here. I just want the day of the week for that particular flight. And this is the execution plan that I wanted to get to. Now, what happens is that we use day of the week is where weekdays DID, which is defined now as a foreign key and is used in the lookup against this day of the week table. So now I have an index join, an index scan here to get the days of the week. Now I have this days, all of the flights, but now they do an inner join, a hash match. We'll see how that's done in a minute, but basically it's building a table, a lookup table of these days of the week, and it's matching them up. And it runs much, much faster, much, much faster. However, the optimizer tries to give us a helpful hint, the missing an index. Now, these missing indexes, I don't necessarily think they're a good idea to put all these indexes out there. We'll see some counterindications for when you should use an index or not. But you're going to get recommendations like that. Now, here's where we're going to deal with those recommendations. We're going to try this query here. Now, what we're doing here, I forget what I'm doing here. I'm doing 3 joins. So this is another example of the same one, but I've added another join. So I have another where clause. And you're going to see a similar execution plan here, but you're going to see another clustered index that's going to get hash match joined to it. Let's execute that. That should run pretty quickly too, because these are hash joins, foreign keys. Taking a little longer. It's done. And my execution plan here is very similar to the other one, to the previous one, but of course I have another at the far edge here. I have a clustered index, one join, and then another clustered index scan and one join. That's logically what I've requested, because I was looking at the flights database and, whoops, I think I'm not showing you the query anymore. The flights database, the weekdays and the carriers, and you're creating those kinds of things. This is where having an index and the foreign key references makes your query run a lot faster, because it can do index lookups. It can use the indexes and not necessarily have to read through all the data. Okay, now, so that was just to get a feel for that. But here's a more like a query that's in your homework. And the reason I'm going through this is somebody asked about this, or one of the TA note out there. So when you execute a query like this, so here are the queries. I'm going to see an origin city like New York, and a destination city like Los Angeles. I'm using the like keyword with a wildcard, because I don't care if it's New York, New York. I just want the first part of the city name that I've got. I'm doing the same where clause, where I'm going to do an equal join. So I've just added this additional where clause here. It's the same as the previous one, but I added an order by at the end. I want to see the carrier's name, price, day of the week. I want a nice report here. Let's execute that. And that ran pretty fast. I may have already set up my, let me see if I did that. I got this thing here. No, it doesn't exist yet. I didn't create the index yet. All right, let's go. Back to here. Let's do this one more time. Whoops. A little faster than I thought it would. And our execution plan, some of our results are being cached in memory at this point, so from previous queries. So that's one of the reasons why it's running so quick. So I've got more than enough room for 1 million rows of this database in this computer. We've got now in our from clause, we've got the flights, we've got the weekdays and the carriers. What we've added is this additional where clause. We're looking at just origin cities named New York, and destinations. They're just looking at flights between New York and Los Angeles. That would be the kind of thing, if you want to, this was part of a reservation system that you would do. I got a clustered index scan, a clustered index scan, a clustered index scan, a hash match, a hash match. It's the same query, though it has this where. And in order to find the values, it is looping through all 101 million rows. And now it's coming back and saying, here's a 70% impact if you wanted to create a non-clustered index on, and it tells you what to create the index on. It also tells you to include some more things, which I think it's a little bit of overkill, but you can create what's known, this is known as a covering index, where all the data, am I using a red button? Where all the data that you want is actually in an index and not in the data. That's known as a covering index. We'll get to some more of this. What I wanted to do as a result, though, is look at the execution plan if we added an additional index or two. If we're going in our reservation system to constantly be searching for flights from or to specific cities, why not create indexes for them? And these are indexes which are not unique, but they help with the lookups and they'll generate better plans. So what I want to do is create those indexes. And that'll take a while because in fact, it's going through the entire flights database. And you can see what it's doing when you do the executions bit. It's scanning all 114 million rows, 1.1 million rows, and it's creating an index on origin city and destination city. Having done that index, let's execute this query again, mindful of the fact that it's probably still in memory. So it's going to run very fast, but you'll see that it's going to get a better looking execution plan. The execution plan here is a little bit more complicated, as you can see, because there's a key lookup that's been added to it, which are these new keys. This is the seek key is looking at, in this case, file ID. At some place, oh, here's the non-clustered index. There's I'm just looking for flights that have destination of Los Angeles, and here I'm just looking at flights that have a destination of New York. So this is called an index seek. I'm going to that index and I'm finding just those values that equal Los Angeles. And here's an estimated cost of that, which is instead of reading all these rows, I'm actually going to have to read 38,000. So I don't have to scan 1.1 million rows again with these indexes set up, which have already basically pre-scanned the data. I can execute this query much, much faster. I realize that's a lot for you to absorb right away. You're going to be running these queries, this type of query. Note, you could turn on explain so that you could see what you're doing. This is one of the reasons why I recommended using a locally installed version of SQL Server so you could play with it a little bit more. I don't know what's trying to do this and creating the indexes will help once you use those indexes frequently, but the actual cost of them, it might be significant. Okay, let me look at your questions. Does the order of the where clauses change execution time? No, not at all. And I can put them anywhere. Where is executed at the beginning, though. And you can see logically that when I had these indexes defined, the SQL Server knew to go to those indexes first to get the data that I wanted, and then do these joins, then do an inner join or do an inner join. So if you set it up right, SQL Server will run very, very smoothly. What happens is there's a syntax checker, and one of the nice things about a tool like this is that, say, I want to do a select statement, and I don't know what I want to select yet. But if I know if I want carriers, and then I can go back here once the tool knows carriers. You can say, well, it'll know what fields are in the carriers table. So there should be like a carrier ID of some kind. I don't know. There it is. So it saves you, and so it's doing a little bit of syntax checking in the tool, so that by the time you send this statement over to SQL Server, it's syntactically correct. Otherwise, you waste a lot of time figuring out the right the right syntax. So that's a little tip. So no, the order of which these things actually is determined, and we'll see that when we look at relational algebra. The order of what this is, that from is done first. It's done at the bottom. If the first layer is to do that as from, and then where. But depending on indexes, this where clause is going to be done different ways. The simplest way to do it is to loop through the entire table and find just those rows that meet the criteria. If I create an index, though, on that particular field, which is the destination city and the origin city, SQL Server, using its estimates of its understanding of what those index values are and how many rows there are associated with different index values, it will decide that I could scan that first and then do the query that much faster. And we're going to get to all that. But anyway, this is the database that you're getting set up. Thought I'd show you the tool and show you what you can do with the tool. And if you'd like, I will post both of these sets of SQL. You can't email SQL around in a lot of places because if you click on it, somebody picks it up and suddenly you've compromised somebody's database. So it's a kind of thing hackers do. But I'll post the text and then you cut and paste into your tool. So get one of these tools. The other tools work similarly. I do a lot of work in SQL, so I'm pretty familiar with this tool. And I use SQL on Windows predominantly or on Azure. If you're running on a Mac, this tool is not available, but I think there's about 3 other possibilities that are very similar kinds of tools. We're going to investigate more of this. Also, the stuff on the left-hand side, this is all the metadata associated with it. Indexes, statistics, various things like that. So we'll learn about more of it as we go. So if you have some questions, I understand that you do, but think about how far we've come in 3 weeks and start working on that homework and be generating a bunch more questions for me. I'm going to go from this. If you have more questions, come over to the, and I didn't get to answer them, come over to the other meeting because we should end this one. Okay? I'm going to end this meeting and start the other one.